Hello and welcome to Modern DevOps, Making the Switch. My name is Mislav Kos and I work at Soliant Consulting as a technical solutions architect. I grew up in Croatia and have lived in Chicago for the past 34 years. I've been doing FileMaker development for over 10 years and I have spoken at two DevCons. The first of these was Demystifying SSL in 2017. And then last year, I co-presented a session with my colleague, Win DeCourt, on server monitoring with Zabbix. I'm going to be talking to you about DevOps, what that is, why you might care about it, how it relates to FileMaker, and how you can start introducing DevOps practices in your own development. And now, without any further ado, let's begin. We'll start with a brief overview of DevOps. Think of an application as consisting of two parts. On the one side, we have data. Data is in the realm of the user. It is created and modified by users. And on the other side, we have code. Code is all the stuff that developers create, like layouts, scripts, data schema, and so on. And the application itself runs in a certain environment, which we'll call the production environment. The goal for DevOps is to deliver functionality, that would be the code, at a fast pace, but without sacrificing quality. Without sacrificing quality means that development changes do not happen in the production environment. We need at least one additional environment where development can happen without affecting production. But having a development environment means that we have to deploy code changes made there to the production environment. And of course, we also have to test before deploying. And so delivering functionality looks like this. And then to support subsequent changes, we need to incorporate feedback. DevOps emphasizes application monitoring to inform the next step, which is to plan the next batch of changes. We can think of this cycle as a loop. DevOps aims to reduce friction in this loop. Let's look at the delivery portion of the loop. To facilitate delivery, DevOps uses several practices that build on each other. There is continuous integration, continuous delivery, and continuous deployment. And the main thrust of these practices is to automate the testing and deployment of code changes. With DevOps, the automation of testing and deployment is closely tied to another key component of software configuration management called revision control. And we'll look at that next. Looking back at the composition of our application, there are a couple of aspects about FileMaker apps that are different from many other software platforms. With other software languages, the code consists of standalone text files. And with FileMaker, the code is embedded in the database file. In some cases, the code is written, and in other cases, the code is configured. But in all cases, the code specification is embedded within the file. But if we open a FileMaker database file in a text editor, we can see that the contents are binary, so it's not like we can see the code in here. These differences in how code is created and stored have some consequences. On the one hand, it is a part of what makes FileMaker so easy to use. Compared to other software platforms, FileMaker has a very low learning curve, and it is also possible to create functionality much more quickly than with other platforms. But these architectural decisions made by Claris long ago do also have some drawbacks. One of these is that it is difficult to do revision control using tools like Git that have become commonplace with other types of software development. Let's take a look at how a revision control tool like Git is used with software languages whose code is organized in standalone text files. When a developer starts to work on a new feature, they create a branch. This branch serves as their private development environment. After they have made some changes, they can commit those changes. This way, as they continue doing additional development, they can always roll back to a previous commit point. Once their changes are complete, they can create a request to pull their code back onto the main branch. This is called a pull request. If that request is accepted, the code is merged back onto that branch. So what does this process look like if there are multiple developers making changes at the same time? The first developer creates his branch and begins development. The second developer then comes along and creates her own branch. Meanwhile, the first developer continues and eventually completes his changes. Once the second developer finishes, her code is ready to be merged onto the main branch as well. But what if the two developers made changes in the same areas of the code? In that case, the merge step now also involves resolving merge conflicts. Revision control tools track changes on a file-by-file basis. Suppose the first developer's work involved making changes to these 3 files. If the second developer didn't touch those files and instead worked in an entirely separate area, then there's no problem. But if the second developer also made changes in the third file, then the merge conflicts will need to be resolved for that file. To minimize the chances of, and also the scale of, merge conflicts, DevOps emphasizes the need to merge code changes into the central repository frequently. Suppose that in this situation, after the first developer made this commit, instead of proceeding to the next commit, he merged the code back onto the main branch. Then the second developer would have been able to create her branch from that point, and there would be fewer changes to have to reconcile later. So how close are we to being able to do revision control with FileMaker? Well, to start with, we would need a way to represent the embedded code as text. And in fact, the Save as XML feature does exactly that. It is available in the Tools menu, and it produces a single XML file that contains all of the code from the database file. A nice to have would be for the XML to be split out into separate files. For example, every script, every custom function, every layout, each one gets its own file instead of being jammed into just a single file. Compartmentalizing the code in this way would make it easier to use modern revision control tools, which expect the code to be organized in multiple files. Then we would need a way to compare 2 XML files, for example, one from our development environment and the other from production, and create a patch file that represents just the changes that were made to the code. If you're familiar with diff tools, these are tools that compare text files and highlight the differences, you may be thinking, well, can't we just use something like that? Unfortunately, because of the way the information in the XML files is structured, it's not as simple as that. This sort of capability, creating patches, that is, doesn't exist quite yet, and because of that, patch files currently have to be created manually. This is a very painstaking process and really isn't a viable method other than just to experiment with the idea. Once we have the patch file, we would need a way to apply it to our target file so that we can deploy the code changes. This is, in a way, the reverse of the first step. We're taking text code and embedding it back into the FileMaker file. And the recently released app upgrade tool does exactly this. At the moment, it exists as a developer preview, and hopefully in the near future, it'll be hardened and will be accompanied with the ability to create patch files. And finally, it would help if this entire process could be scripted or automated using the admin API. That way, a human wouldn't have to be involved by, for example, clicking on the Save as XML command in the Tools menu. We just finished taking a high-level view at revision control, and with that knowledge under our belt, let's talk a bit about testing. It's probably safe to say that most FileMaker testing is done manually. So how does automated testing compare to manual testing? To start with, let's recognize that it would be quite a bit more work to set up automated testing. But once it's set up, you could run those tests quickly. And they would offer a systematic approach to testing. You would no longer be relying on how motivated and focused your tester happens to be at the time when they're doing the testing. And having a comprehensive suite of automated tests would be really useful for regression testing, the goal of which is to make sure that our code changes didn't break any existing functionality. So if we were to do automated testing, how would we go about it? Let's start by taking a look at a type of low-level test called the unit test. To do unit testing, software has to be organized in small testable units. Each code unit takes some input and produces some output. The code units would have to be fairly narrow in scope, and ideally they do not require any external resources like network resources or databases or the file system. The unit tests would vary the inputs and then compare actual output to expected output. We can see an example of this by taking a look at a FileMaker custom function. Suppose we have a custom function that returns the cube of a number. If we pass in the number 2, we would expect to get back 8. If we pass in -3, we expect to get back -27. And we'll define our edge cases like this. If a number is empty, return empty. And if a number is not really a number, return a question mark. We can write our custom function like this. And if we want to test it out manually, we could do so using the data viewer. So how would we automate unit testing for this custom function? Well, we could write a script like this one. We define our unit tests up front, along with the inputs and expected outputs. Then we run our tests, collect the actual outputs, and compare them to the expected outputs. And at the end, we report on the result. Now let's suppose that a developer changes the custom function in a way that causes it not to work properly anymore. If we now run our test script, it will let us know. So what about unit testing for scripts? With custom functions, our input is typically in the form of parameters, and the output is in the form of a result. But scripted workflows often have a reliance on external resources like record data, in addition to just plain old parameters and results. Users enter or modify data along the way, and the outcome of the workflow is that the script itself also creates some records. And this complicates creating automated tests quite a bit, but it is still possible to achieve some level of automation. One tool that can be helpful for this is AppleScript, which can be used to automate user interactions. My colleague July Belber recently wrote about her experience creating automated tests. So if you're interested, you can read more about that here. We've talked a bit about test automation in FileMaker. Now let's see how DevOps envisions automated testing to fit in with revision control. Essentially, whenever code is merged back onto the main branch, the suite of automated tests should be run, not manually by a developer issuing a command to do this, but automatically. We can't use revision control with FileMaker just yet, and creating a fully comprehensive suite of tests will likely be more work than it's worth, but it's important not to get caught in all or nothing thinking. Instead, our tasks should be figuring out how to get closer to the ideal state than we are now. If you have complex and highly critical workflows in your solution, those would be good candidates for investing the time and effort to build out automated tests. Deploying is simply replacing production code with development code, or at least that's generally the most critical step of a deployment. If the code existed in standalone text files, this would be a fairly simple task. But because FileMaker code is embedded inside the database file together with data, this task becomes more complicated. Let's take a look at several different FileMaker deployment models. With live development, changes are made directly in production. This approach removes the need for deployment, but it carries with it serious quality implications. I refer to the next deployment model as manual or piecemeal deployment. Here, development changes are made in a development environment, and as those changes are made, the developer has to take careful notes of what was done. Then when it's time to deploy, the developer has to manually recreate those changes in production. An advantage of this approach is that it makes it possible to deploy a specific change without deploying any of the other work that is still in progress. However, this model is a very frustrating experience for the developer since deploying changes requires a lot of manual work. And it is also error-prone since it relies on the developer remembering to take detailed notes every step of the way. Code changes also have to be recreated in the production environment in a very particular sequence. For instance, changes to tables and fields have to be made before any scripts are updated. And finally, with this model, deployments are not easily repeatable. For example, if you need to release code to multiple production environments, you will have to do this manually for each one. The next deployment model is an improvement on the previous one. With this model, the solution is split into two files: a data file, which is where all of the record data resides, and an interface file, which is where all of the code is intended to reside. The idea is that when it's time to deploy code changes, you can simply replace the interface file in production with the one from development. But unfortunately, it is not possible to completely decouple the data from the code in a FileMaker solution. For example, think of all those field calculations or the relationship graph. And in my experience, most deployments involve making at least some changes to the data file. And so then we're back to having to do manual deployment for those kinds of changes. Something else to consider with this deployment model, when internal authentication is used, new or changed passwords will be lost when you swap out the interface file. The next deployment model gets us even closer to where we'd like to be. With this approach, the developer creates a data migration script, which uses the import records script step to transfer record data from the production file to a clone of the development file. For a long time, this was the best deployment model available. But if there is a lot of data, it can take a very long time to run, as in hours or even days. And the migration script has to be kept up to date whenever any changes are made to the database schema. And this brings us to the Data Migration Tool, which was released a few years ago. For on-premise installations of FileMaker Server, this tool is a standalone command line program. And for FileMaker Cloud, it is part of the admin API. We will take a much closer look at how it works later on, but for now I'll just say that this is the recommended approach, as it makes deployments a lot easier to do than any of the other options that we've looked at thus far. The last deployment option is the App Upgrade tool. It is intended for situations where the code changes are small in scope, and the deployment is really about patching the production app with that small change. This tool was released recently as a developer preview, and it's currently not yet feasible to use in production, but it is very promising, and it will eventually be another arrow in the quiver. From a DevOps perspective, the goal is to move from deployments that require manual action to ones that are increasingly automated. With one level of automation, the deployment could be as simple as issuing a single command. And at the extreme end, the code is deployed completely automatically without any human intervention whatsoever, as soon as it is merged back to the main code branch, and of course, provided that it passes all automated tests. And so every time that a feature is checked back in, and the tests are run, and the code is deployed to production, and all this happens completely automatically. The key principle here is that when code is merged, we deploy automatically if the code passes all of our automated tests. Earlier on, we introduced this notion of continuous DevOps practices. Let's go back to this now and see how revision control, automated testing, and automated deployment fit in with these three practices. With continuous integration, code changes are merged frequently, as in daily, into a central repository. Unit tests that have been created are run automatically whenever code is checked in. And the code build also happens automatically. This is more relevant to software languages that need to be compiled before they can be run, but this doesn't just have to do with compiling code. For instance, if we're using a JavaScript library, the build process would be where we would want to make sure that the version of the library is consistent across all of our environments. Continuous delivery builds upon continuous integration in that if you're doing continuous delivery, you're also doing all that is entailed in continuous integration plus more. For example, in addition to running your automated unit tests, you also run whatever other test automation you have in place. And as for deployments, as soon as code is checked in, and provided that all of the automated tests pass, deploying to production is a single command away, but it does still involve the approval and involvement of a human being. And that is in contrast to the next level called continuous deployment, where even deployments happen entirely automatically. No manual approval is required. Looking back at the development cycle loop, the question is, how do we move the needle to get as close as we can to achieving the goals of DevOps? We want to focus on the areas that we have greatest influence over. With testing, we can set up test scripts and make use of automation tools like AppleScript. With deployments, we can use the Data Migration Tool, which we'll look at more closely later on. And in the hopefully not too distant future, we will also be able to make use of the App Upgrade tool. And with monitoring, we can use tools like Zabbix and techniques like usage listeners. Zabbix is an open source tool that can be used to monitor your various different environments. I won't focus on Zabbix here, but my colleague Wim de Kort and I did a session on Zabbix last year, so you can check that out if you'd like to learn more. And if you're interested in gaining greater insight into how users are using your solution, check out Bill Bennett's session from this year's Claris Engage called Usage Listeners. In that session, Bill, who is the founder of Kiza Solutions, walks you through how to use layout and script listeners, as he calls them, to report on usage activity. The log data that is accumulated could then be examined with a schedule, for example, and it would then be fairly straightforward to send out notification emails when certain conditions occur. So this could be a good way of establishing monitoring of your application. Thus far, we have looked at how to get closer to DevOps practices relating to testing and monitoring. And we'll talk more about deployments in the next chapter. But now let's take a look at how Agile Planning can be used to plan and organize your development efforts. In particular, we'll look at how a tool like Jira can be used for this purpose. Jira is made by a company called Atlassian, and there are two primary ways of doing your Agile planning with Jira. You can follow the Scrum Agile process, or you can use the Kanban method. At Soliant Consulting, where I work, we follow Scrum for our project work. But there is a place for Kanban as well, and it is a bit simpler to do. I'm going to give a demo of Kanban in a moment, and so I won't talk much more about Scrum here, but if you're interested in learning more about Scrum, here are some resources for you to check out. The first is a fairly short 20-page PDF, freely available online, called The Scrum Guide, written by Ken Schraber and Jeff Sutherland. And the other one is a book called More Effective Agile by Steve McConnell. There are two concepts that are used with both Scrum and Kanban that I'll introduce here. The first is the backlog. This is where new features, change requests, and basically all new desired development work is identified and tracked in the form of Jira tickets. And the other concept is this notion of a board, and it is used to track progress. And we'll see a demo of both of these next. All right, so this is what a backlog looks like. We have already created a set of tickets here that represent the development work that we'd like to do. And we have tagged the tickets so that we know what functional area each one belongs to. And we have also assigned a version to each ticket. This way we're able to do some release planning so that we have an idea of which batch of tickets we'll work on next, which ones come after that, and so on. Jira makes it possible to filter the backlog by epochs, which I'm using here to group tickets by functional area. And we can also filter the backlog by version number. The way it works with Kanban, once we have our next version planned, we move the tickets to the to-do area. And this causes them to be displayed on the board, which is what we're seeing here. The columns are entirely configurable, and what we're seeing here is simply a configuration that I've used in the past and that has worked well for me when deploying code changes using the Data Migration Tool. But you can change this to accommodate your particular development process. So once the developers, and in this case there are two of them, once they're ready to start working, they can move their tickets to the in progress column. This makes it possible for everyone on the team to keep track of progress. When development is finished for a ticket, it is moved to the verify column and assigned to the tester. And in this way, tickets move from the left to the right. Eventually, all of the tickets accumulate in the ready to deploy column. Because in our example here, we will be deploying using the Data Migration Tool, the code in our production solution will be replaced entirely with the code from our development environment. What this means is that we can't have any tickets left in progress or in the verify column, because those two columns are used to indicate that there is still work in progress, and so the solution is not yet ready to be deployed. This is perhaps obvious to you, but if you're used to what I referred to earlier as the manual or piecemeal deployment model, then you're used to being able to progress a ticket from the leftmost column all the way to the rightmost column independent of any other ticket. In other words, you're used to being able to deploy each piece that you're working on independently of any other work that is happening. This means that using the data migration tool imposes a constraint since all of the tickets have to be deployed together. But on the whole, this downside is far outweighed by the benefits gained by using the tool. And it may feel a little funny at first, and you may feel reluctant to make the switch, but I promise you it is worth it. And after you've done a few deployments with the data migration tool, you'll wonder how you ever lived without it. Once the deployment is done, all of the tickets are moved to the Done column. And they are then released using this button here. All of the previous releases can then be viewed using this navigation link over here. If you'd like to learn more about how to group your development into releases, you can check out Sarah Severson's session on release planning. We're now finally ready to take a close look at how the data migration tool works. We have our two environments. In the development environment, developers are making changes to the code. And meanwhile, in the production environment, users are making changes to the data. And what we want to do is to replace the production code with the new code that we have in the development environment. So the first step is to create a clone of the development file. A clone is simply a copy of the file that has all of the code and none of the data. It can be created as part of a FileMaker server backup schedule, or you can close the file on the server and then open it locally and create a clone from there. There is something special about how FileMaker creates a clone, though. As soon as you open a clone file, FileMaker will write some metadata to it. For example, localization information about how dates should be formatted. And as a result, that file will no longer be considered a clone. So make sure you don't open your clone files. Otherwise, they will be rendered unusable for the purposes of the data migration tool. The next step is to migrate the data from production. This is where the data migration tool comes into play. Once it finishes migrating the data, our target file has the data from production and the code from development. The third step is to replace the production file with our migrated target file. I'm going to add a fourth step here, and that is to refresh our development environment so that it exactly resembles production. Strictly speaking, this is an optional step, but I don't think of it as an optional step because it is very important to have a fresh set of data in development so that as you work on the next set of changes, you're able to work with the data that accurately reflects what is happening in production. Without this step, the data in development will get more and more stale over time, and this can lead to the introduction of defects. Going back to the second step, let's take a more granular look at how the data migration tool works. The data is migrated one table at a time. Each table can be migrated in a fast mode or a slow mode. The data migration tool determines which mode it will use for each table automatically, depending on the type of development changes that were made in that table. For example, if a field was added to a table, migration can still happen using the faster block mode. But if the calculation of a stored calculation field has changed, then the slower record mode will be used to migrate the data for that table. This means that duration of how long it will take for the tool to run can vary from one deployment to the next. And we can see an example of that here. These are durations for an app that is approximately 4 gigabytes in size. And this data was taken over a period of approximately 1 year. We can see from this that the duration here has been as fast as 3 minutes and as slow as 24 minutes. In the previous chapter, we saw that deploying code using the data migration tool involves these 4 steps. This is a high-level view, though. At a more granular level, your deployment process will include some additional steps. Let's now take a look at one possible way to structure your deployment. The first step would be to do some pre-processing on the development file that is to be deployed. This is essentially our final prep for that file before we create a clone from it. Some examples of the kinds of things we might do here include checking to see if someone has created a table or a field directly in production as part of a hotfix, but neglected to create that same table or field in the development environment. If that happened, then that record data would not migrate during the deployment, and as a result, it would be lost. One way to do this check is to sort the fields by creation order, and another way is to query the virtual schema using execute SQL, which you can learn more about by reading this blog post here. Another example is undoing any changes that were made in development that were intended to be temporary and whose purpose was just to make the developer's life a bit easier. For example, maybe you're working on a script and you wanted to be able to call that script from the scripts menu so that you could access it more easily while you're testing. But once you're ready to deploy, you don't want the users to see it there. And a third example of the kinds of things we might do as part of pre-processing would be to hide any changes or new features that are still in progress and aren't ready to be released to users. This could be as simple as hiding the navigation button that takes the user to that new admin layout you've been building. The next step is to create a clone of the development file. This will typically be done using a server backup schedule. Once we have the clone, we'll need to move it to production. Clones are generally not very big in size, but if you happen to have a particularly large clone file or set of files, you could compress those first so that they're copied over the network more quickly. Once the code has been copied over, you'll need to put it in a folder someplace. And here's one way that you could organize your folders for your deployments. Here we see a releases parent folder, inside of which are all of the other folders. We have a folder for the Data Migration Tool program, and keeping the version in that folder name makes it possible to quickly see what version we're using. And then we have a timestamp folder for each release that we've done. Inside each individual release folder, we have these three subfolders. The source folder is for the production file, which has the data we want to migrate. And the target folder is where the data migration tool will create the migrated file. Instead of creating a folder structure like this, you could also just place the clone file directly next to the source file in your databases folder. This will save you some time later on because you won't have to copy the migrated file anywhere. But personally, I prefer the organization of the folder structure I showed before, but there is an argument for doing it this way too. The next step is to close the file that is hosted on production. This involves disconnecting users, which means that this is when your outage starts. Up to this point, users were still able to work in the solution, but not anymore. We're now ready to run the data migration tool. If your solution consists of multiple files, there is a trick to shortening the overall time for how long it takes the data migration tool to run, and we'll get to that a bit later on. A common question that people have with the data migration tool is how should container fields be handled? And we're talking about containers with external storage here. The nice thing about it is that you don't have to do anything. Since those container files are stored externally, they will simply stay in place. Once the previous production file is replaced with the migrated file, the container fields will have the same paths as before, pointing to those external files, so everything will just work. When you run the data migration tool, which is a command line tool, the output will be written to the command line window. But the tool does not automatically save that output in a log file. And that is unfortunate because after the tool runs, it's important to inspect that output to see if there were any errors. And that's a lot easier to do if you're able to look at that information in a text editor or a log viewer. So you'll want to make sure you capture the log yourself. This could be done by redirecting the output to a log file using the redirect operator. But then you would no longer see it on the screen. So you would lose the ability to quickly and easily track the progress of the tool as it migrates the file. Fortunately, on Windows anyways, you can use this command in a PowerShell window to both redirect the output to a log file and display it on screen. The tool does have an option to display extra information, and the first few times when I used the tool, I enabled this because I figured more information is better. But I have since changed my mind about this. All of the information you need to know is included with the default level of output, And the verbose mode, in my view, just adds noise to the overall picture. When reviewing the log file, the summary section at the end is the most important one, so I recommend you start there. Here's an example of what that summary section looks like. When looking at it, check to see if any tables weren't migrated or fields, or if any of the stored calculation fields had errors as those calculations were reevaluated. In this case, all three show zeros, which is what we want to see. In this example, one of the calculation fields had an evaluation error. Now we need to find out what field this is referring to. If we scroll up in the log file, we'll find an entry like this one. I do see this particular kind of error every so often, and I'm not sure what causes it. But to fix it, we need to force the calculation field to reevaluate. One way to do this is to make a trivial change to the calculation expression, like appending an empty string. This won't change the calculation result, but it will cause it to reevaluate. Here's another example. Here we have several fields which did not migrate. To find these fields, we need to search for the text "no compatible target found for source field." This is telling us that there is a field in the production file which could not be migrated. In the example shown here, the reason was because a stored calculation field was converted to an unstored calculation. And as a result, the stored record data from the production file didn't have anywhere to go in the target. While we're here, let's take a look at this other pair of log entries. Here we have a similar but slightly different message. In this case, there's a pair of fields that were created in the development environment. And since these fields don't yet exist in the production file, which is referred to as the source file here, there is no data to migrate. In other words, this is an expected log message that we can safely ignore. After reviewing the log file, we're ready to do any post-processing that may be required. The most common task that you'll do here is to initialize record data for new fields. If you add a field during your development cycle, that field won't exist yet in production, and so there won't be any data migrated for that field. In some cases, that'll be just fine. The data will get populated in that field over time. But it's not uncommon that you'll want to initialize newly created fields with data as part of your deployment. This initialization could be done manually using replaced field contents or by importing records. But you could also handle this by creating a script that initializes the field. This script would be run only once during this post-processing step, but the advantage of that is that it makes this step of your deployment that simple. You just run the script and that's that. Here's another example of a post-processing task. You may want to make changes to the file options settings. Most of these changes can only be done while the file is not being hosted on the server, so this is a good time to take care of those kinds of changes. And the last example is creating or changing FileMaker service schedules as needed to support the new features or changes that were made during the development. Once the post-processing tasks have been done, you're ready to replace the original production file and rehost the file. After the file has been hosted, it's time to do QA. Your changes should have gone through testing by this point. So the goal here is not so much to do functional testing of those changes. Instead, the focus should be on doing integration testing for those features that rely on settings or external factors that are different in production than in development. For example, maybe you have a web service integration where the URL and the credentials are different in development. In this case, just because everything worked there doesn't mean it will work correctly in production. At the start of this chapter, I mentioned that this checklist that we're going through now is just one possible way of organizing your deployment tasks. And an example of how this checklist could vary is that if the person doing the deployment is the same person who will be doing the testing, he or she may decide to do this QA step before the previous post-processing step. Otherwise, you will need to have some type of access controls in place in the onOpen script so that users aren't able to access the solution just yet. If your testing reveals problems that aren't able to be addressed quickly, you will need to revert back to the original production file. If you organize your folders in a way that I talked about earlier, then the production file is waiting for you in the source folder. Otherwise, you will want to make sure to include a step earlier in this process or in this checklist to create a backup of your solution. If the solution passed QA, then it's time to notify stakeholders and users that the outage is over. If you had some sort of access controls in place in the unopened script, you will want to disable these at this point. The deployment is technically over now, but there are still some cleanup steps to do. One of these is to refresh the data in the development environment. Without doing this, your future development will use older data that will over time increasingly diverge from what is in production. Another of these cleanup steps is to release in Jira the tickets that were just deployed. Back in the Jira board, we can use the release button to do this. Jira makes it possible to view all releases, both those that have been deployed already and those that are still planned. And we can view the details of any of those to see which tickets were a part of it. The last step in our checklist is to generate a DDR. It is generally a good idea to have a fresh DDR readily available. This step is more relevant for larger multi-file solutions where it can take a long time to generate a DDR. So here's our entire deployment checklist. We can see that the outage is just one segment of the overall deployment. And of course, running the data migration tool is just one step in the overall process. In this final chapter, we will wrap up by taking a look at a couple of smaller miscellaneous topics relating to using the data migration tool. Here's the deployment checklist again, the one we covered in the previous chapter. We talked about how the data migration tool automates the moving of data to the file that is to be deployed. But the rest of these deployment steps will have to be done manually. Could some of those be automated? There are a couple of tools that aim to do this. Two of these are Auto from Geist Interactive and 360 Deploy from 360works. These tools will automate the steps highlighted in orange. And if you host your solution with FileMaker Cloud, the version of the admin API that runs there can be used to run the data migration tool in a way that automates these two tasks shown here. Now let's take a look at how we can deploy solutions that consist of multiple FileMaker files. Here's an example of a solution that has 9 files of varying sizes. The largest file took 34 minutes to migrate. The next largest one took 18 minutes, then 19 minutes, and so on. We can see that the overall duration for how long it took to run the tool was 86 minutes. And that's quite a long time. So could that be optimized? As I mentioned in an earlier chapter, it is possible to run multiple instances of the data migration tool at the same time. When we ran 2 concurrent instances, we were able to achieve a much faster overall duration. And when we used 3 concurrent instances, it got even better. Here we were able to reduce the duration from 86 minutes to 38 minutes. At some point, though, increasing the number of concurrent instances won't help and may in fact start to have an adverse effect. We can see in this example that our bottleneck now is the largest file. Using 4 concurrent instances won't make the processing of that one file any faster. And every additional concurrent instance uses up resources like CPU and memory, so that needs to be considered as well. This blog post goes into more details about how to organize deployments for multi-file solutions. In particular, there's a tool that my colleague Brian Engert developed that makes it a lot easier to handle these kinds of deployments. The tool is called YaDMT, which stands for Yet Another Data Migration Tool. It is free and open source. It automatically chooses the sequence of which file should be migrated first. It then runs the migrations in multiple concurrent instances. It automatically saves the log file for you. Without this tool, you have to type out the data migration command separately for each file, but this tool makes it possible to run just a single command to migrate all of the files, so it's quite a bit more convenient. And finally, it's possible to set it up with a configuration file so that running the tool can be completely automated and doesn't have to involve any manual input. You can download and read more about this tool here. The next of these mini topics that I'd like to cover as we wrap up here is how to handle hotfixes. Hotfixes are changes that fall outside of the normal deployment process because they need to be pushed to production immediately. This is done for critical bug fixes that cannot wait until the next deployment. Developers are under pressure to make these changes quickly, and so there is a temptation to do the work directly in production. But the proper way of doing a hotfix is to make the change in development first, then test it out there, and then deploy it to production using the manual or piecemeal deployment method. There are several reasons for this. The first is that if you do live development, you could make a mistake and end up exacerbating the problem even further. The second is that if you make changes directly in production, it becomes easy to forget to also make those same changes in the development environment. But if that were to happen, then during the next normal deployment using the data migration tool, whatever changes were made in production would be lost. So the changes have to be made in the development environment regardless. And because that's true, we may as well make them there first, and then test, and then manually deploy them to production. There is also another reason to be careful to always make the same changes in both the development and production environments. Suppose that as part of a hotfix, you create a new field named type in production. Every FileMaker field has an internal serial number ID that is automatically assigned. And let's suppose that our type field is assigned 89 for the ID. Meanwhile, at some other point in your development cycle, you create these 3 new fields in the development environment in that same table. The first of these will get assigned the next available internal ID, which will be 89. Then when the data migration tool runs, it will match up tables and fields in the 2 files, the clone file from your development and the source file from your production, using the following matching rules. It will first try to find a match by both name and ID. And in almost all cases, it will be able to find a match that way. But if it doesn't, it will try to find a match by name, and then it will try by ID. In our situation, it'll end up matching the type field in production with the vendor field in development, because the IDs are the same. This will result in data being migrated into the wrong field. So always make sure to make your hotfix changes in the development environment first, and then test and then deploy them to production. We're at the very end now. If you aren't already using the data migration tool, hopefully by now you are convinced that you should be. But for those of you who are responsible for solutions that are highly critical to the business, you may still have some reservations about it. Changing a process that is as critical as deploying upgrades to a solution is a big deal, so you may be hesitant to proceed. So here are some tips on how to make that switch. First, make sure that your production server has adequate computing resources to handle running the data migration tool. In most cases, it will. But if you have a multi-file solution and your goal is to make the duration of how long the tool runs as short as possible, you will want to pay attention to the performance and availability of your server resources. For example, in our testing, we have found that each instance of the data migration tool pre-allocates about 3 gigabytes of memory. So if you're planning on running 5 concurrent instances, you will want to make sure that you have at least 15 gigabytes of memory available. To reduce the stress of a deployment and minimize the chances of making mistakes, I suggest you prepare a checklist ahead of time, like the one that we saw in the previous chapter. You could also take it a step further and write up a detailed procedure for yourself that has extra notes included for each step in the checklist. And the final piece of advice to ease your transition to this new way of deploying is to do a mock deployment. This would involve going through all of the steps, except that you won't actually replace the production file with the migrated file. This will give you a chance to do a sort of dress rehearsal so that the whole process is moved from an abstract concept to a real thing, and all that without a stress of a real-life development or real-life deployment. And it'll give you a better idea of how long the whole thing will take to complete. And that takes us to the end. I hope that you found this session informative and that you feel inspired to find ways of moving components of your development cycle closer to the ideals of DevOps. Thanks for watching.